Fantastic. Well, we're here with Ray Gibbs, CEO and co-founder of Haydale Plc from Wales. Thank you for coming.
Thank you very much, Steve.
Congratulations on being a FiReStarter company this year. This
very happy with that. Thank you.
Great timing too, because there's tremendous amount of activity in graphene. Mark Anderson is a big champion of graphene. Very optimistic about its applications, but we know that there's a lot of work, and that Haydale is right at the center of a lot of this work. So we want to get into today about Haydale, the vision behind the company, the technology, what differentiates it, what are the opportunities, and where do you see things going over the next couple of years?
That's a big list.
Let's start about the vision. I mean, you functionalize graphene. We talk about the F word, right?
Correct.
You're a fan of the F word.
I am
Drop
indeed.
it a lot. What is it about the F word why do we need to pay attention to functionalizing graphene?
Well, graphene's carbon, okay?
Yeah.
Carbon's inert, doesn't want to mix with things.
Yeah.
It's very happy being together. And as you know, graphene is a single layer sheet of atomic carbon layers, yeah? 3 million of these sheets are 1 millimeter thick. But you've got to, if you're going to get all these fantastic properties that everyone talks about, you've got to disperse them into whatever material you're going to put them into. And the only real way that we know is you thrash it through mechanistically, or you use the functionalization, the F word,
right,
to add Velcro, little Velcro hooks, chemical groups, which is compatible with the material you're trying to put it into. And what that does is it disperses it evenly, homogeneously across the material, and gives you a good increase in performance of both thermal, structural strength, stiffness, many other things.
Right. So how do you functionalize graphene? You have a unique process, right?
Yeah, we don't make the raw material. We take it from other people who make it and give it to us, and we assess what they've got. What we do is we have a plasma, a low temperature plasma, which is sub 100 degrees C. We put the material in a vacuum. Mm-hmm. We fire the plasma up, and it's in a rotating drum. It's patented. It's just gone out into China, and we're putting it out elsewhere in the world as well. Mm-hmm. And this technology, it strips some of the molecules, some of the atoms off of the surface and ends of the material. Mm-hmm. And then we flood the chamber with the gas, and that it's the destabilized structures. What they do is they grab hold of the inbound gas, oxygen, carboxylic, whatever it might be. Mm-hmm. The range is immense, so we can play tunes however we deem to need.
Right. And so when you functionalize graphene, is it like you're tuning it for particular applications so you can get some game-changing applications that you can't get with other materials?
Yeah, absolutely.
And it's a science, right?
Yeah, because and it's still a journey. It mm-hmm. always will be a journey. Yeah. We know that you can over-functionalize, you can add too many things to it. Okay. And what we do is we know that there's a certain level, and we can run the reactor for a small period of time, or a standard period of time, or longer. And we know that the level of functionalization varies between the amount of time the material is spent in a reactor.
Right. Now, you're in Wales. University of Manchester is where graphene was discovered.
Correct.
There's a lot going on in Europe. Are you working with the flagship? What's going on? I mean, it's hot over there, right?
So there's 100 million euros a year to capture, eh? So it's bound to be hot, yeah?
Right.
But it's not the only hotbed. The Far East is busy too. The Koreans are very active. They're putting a lot of effort into getting carbon nanotubes to going, which is the rolled up sheets of graphene. Right. And then they've also stated that they're going to put a lot of effort into graphene themselves as well. Right. But Manchester, yeah, we're working with Manchester. There's a lot of activity there. They've got their new facility, which only takes it up to a technical readiness level of about 3 or 4. Mm-hmm. And to get it commercial, you need to be 8 or 9. Right. And they're pushing that on, but there'll be a couple of years yet. Okay, so most people haven't heard about functionalization. It's critical. We know that. You're doing something very important. How do you educate the customers on the need to functionalize, and how do you collaborate with them to get them to have the products that they want to have, right? Because you're an enabler. Haydale's an enabler, correct? Right? Yeah. So how do you enable, say, an established company that wants to bring out, say, a new innovative product? How do you go about doing that? Well, aerospace. I mean, you can think of a lot of applications, right? I have a phrase, everyone's a customer. It's never going to be like that, but there's the raw material suppliers, and we can help them get up the value chain by making their properties of their performance of their material much better.
Right.
Yeah.
Right.
So that helps them,
Okay.
and they may have customers. So we get demand pull that way.
Right.
And then we're currently announcing some work with Huntsman, very large American resin epoxy. Yes.
Congratulations.
Thank you very much.
Yeah.
Now they are a route to market. So we give them a resin infused epoxy with our material, and they'll go off and sell it into the marketplace for specific applications, be it the wind turbine blade, whatever.
Right.
So you have to work with them collaboratively. There's a need as well to have what we say verified by someone else on a third-party basis. Very important.
Right.
That's where the National Physical Laboratory came in,
Yep.
the Aerospace Corporation.
Right.
We've done some work with Cardiff University and a range of other people.
Right.
Third-party verification, crucial, particularly in a new material when you're putting it into the marketplace.
So when do we see functionalization of graphene really start to take hold in the market, really start to change the dynamics of innovation? Is that something that's going on right now? Is that something that's going on in the year ahead? I mean, how far, right, we've got a lot of hype around graphene, and I know that you're all over the world, you're everywhere right now. There's a lot of demand for what you're doing, right? But there's a lot of work that needs to be done. There's a lot of research going into what you're doing, right?
Yeah.
And you guys are you're a publicly traded company now,
Correct.
right? So you've got those demands on you. So where do you see Haydale in the next 6 to 12 months?
Well, I think there's two strings here. Apart from having centres of excellence around the world, and we're putting one in Buffalo, we're going into the Far East, because it's an area where they're demanding local expertise.
Sure.
Yeah, and
Yeah.
we can't do everything from Wales.
Yeah.
We'd like to try, but it's not possible and practical.
Right.
Right. So what we do is we're putting our machines into strategic locations. Germany is another area too. Okay. So what is also happening is we're looking at generating a lot of inbound work from customers. The grant application side is also critical important too.
Sure.
Yeah, it's the level.
You just got a grant, didn't you?
Absolutely, loads of things are happening there. There's an awful lot of activity in the UK.
Yeah.
But it's the applications teams, the Huntsmans, the Scott Barders. I think the composite world is going to be a really big driver of this change.
Right.
Because we are changing the physical properties of the resin by a magnitude of 2 or 3 times, such that it becomes a very integral part in the mechanical computation of a glass fiber or carbon fiber layup. If you create that, increase the mechanical properties, what you're doing is you're actually enabling a layer or 2 layers or maybe more of the carbon or the glass fiber to be taken out of the material that you're trying to make, making it lighter. Same strength, same performance, but lighter. And that saves time, which is cost, and it actually means you're not trucking so many tons around the world.
Okay, I've got to ask you one more question, because we know Mark's a big fan of 3D printing and graphene, right? Let's just talk about, how do you see functionalization of graphene playing into the additive manufacturing environment? Is there an opportunity there?
Oh yeah, it'd be massive, but it's not an easy lift.
Right.
3D printing is good at the moment for metal matrix composites and the likes, because you can sinter the metal. Yeah.
Okay, yep.
Therefore, they bond, no issue. When you've got a polymer, you're trying to sinter it as well. That has an issue because the polymer gets into melt mode, and there's awful lots of issues that need to be resolved. We are, however, making some inroads, particularly into PLA.
Fantastic. Well, congratulations again on being a FiReStarter company this year.
Thank you.
We're delighted to have you. It's a big deal. We're looking forward to hearing more about your technology and the company at this event. Very exciting times.
Thank you very much,
you,
Steve.
Ray.
Thank you.
Yep.